In this video tutorial, we'll look at how to use the Wireshark network analyzer. Now, as soon as you open Wireshark, you will find this interface which confronts you. So let's go ahead and start capturing. So we select an interface, and in this case, I'm going to select the VMware virtual adapter, right? So now if you notice, you've been confronted by another screen which gives you the capture options. Now the first and foremost thing to look here is whether you want to capture in promiscuous mode or not. If you allow promiscuous mode, then you will be able to see all the traffic which is passing by your broadcast domain. This would be for other hosts as well. And if you uncheck the promiscuous mode, then you can only see packets which are destined to you or are broadcast or multicast in nature. So let's keep the capture packets in promiscuous mode checked. Another thing is if you want to update the list of packets in real time and hide the capture info dialog. This is just more of a viewability issue. So let's first go ahead and start the capture. Now in this video, the current network actually consists of this local computer along with a virtual computer connected through VMware. So let's go ahead and generate a little bit of traffic here. So I'm connected via SSH to this virtual computer. So let me start a ping, right? So let me stop this and let's have a look at what Wireshark shows us. So if you actually look here, you must be seeing that we can see an ICMP echo request and an ICMP echo reply. We sort of make the screen slightly bigger, the font, so that you can see it properly. Right? So these are the ping requests and these are the ping response, which we've currently sent and received. So now if you actually look at what we have here, as soon as you select a packet, you will get more details on it. So the first thing is basically the details of the frame. When was the packet actually captured? What is the length of the packet? What is the capture length? So on and so forth. So the next header is the Ethernet header, right? And as you can see, we have the destination address and the source Ethernet address and the type of the packet, which is going to be encapsulated within the Ethernet, which is IP in this case. Then after that, the IP header starts as expected, and you can go ahead and have a look at what the IP header says. So this is sort of a synopsis which says the source address, destination address, so on and so forth. But if you sort of map it with the IP header, then you'll see that first we have the version length, then we have the header length, then we have basically the differentiated service, then the total length. After that you have the identification or the ID, then you have the flags, right? And of course, you have the TTL and the protocol which is encapsulated within, which in this case is going to be ICMP, because it's a ping request and response. Then the header checksum, and finally the source address and the destination IP address, right? And now as expected, after the IP address, what we would get to see is the ICMP header, because it's a ping request and the type is ping request. Of course, then you have each checksum and all that, and then finally the data which follows, right? And to this we receive a ping response. Now if you look at it, most of the things remain the same apart from the fact that the reply is now ping reply. Once again you have the request and reply packets. So using Wireshark, we can actually peer into what is being sent out on the network, and this is something which is very useful. Now let's